Hey, a little bit more with surface area. On this one, we're going to go over cones and spheres. We're not going to go super in depth to why these equations necessarily work out. There is a little bit of explanation on some of it here, but we kind of sometimes just have to run through the formula a little bit because the math that we would use to show why that works is a little more than we are able to cover in this one. But today, again, surface area of cones and spheres. If you do want to see a little bit, the surface area of a sphere, the equation for that is 4 pi r squared. And if you remember from last week, the area of one single circle is pi r squared, and this is 4 of them. So it's kind of like, why is the surface area 4 of these circles? And this video kind of goes through that a little bit. It does go far more in depth if you watch the entire thing. It's like 17 minutes long. It's a very good video, but if you just want to see that a little bit, I have it starting here. If you click on this, it'll start at 126. And if you watch about 1 minute, he kind of goes over, why does this happen to work out? Why does the equation become 4 pi r squared? So if you do want to see that, go ahead and open that video there. And, it does a pretty good visualization of why that ends up working out. But to utilize that, it's pretty straightforward here. I mean, here, all we have to do is figure out what the radius of a sphere is, and it's always going to be half the diameter. We have to be careful that we don't accidentally pick the diameter. And then in here, what we would do is we would just say, well, okay, that's got to be 4 times pi times the radius squared. Okay, that's what we would put in there. And again, you can leave this in terms of pi, and that's what we would work out here. I'd take 4 times, well, 5 squared is 25, so 4 times 25 is 100 pi. And we can leave this right in terms of pi. If you want to change this to a decimal and be like 314 point something, I forget what the rest of them are, you can go ahead and do that, and that's perfectly fine. But if you want to leave it in terms of pi as well, you can. All right. So that's pretty much it. Like, it's just following through on that formula. Which, lots of websites would have that on there too. We'd have that. Okay. Surface area of a cone is a little bit different. If we take a cone and sort of unravel it and try and flatten it out, we can take the top of the cone and sort of open it up. That's where this yellow circle comes from. You kind of pull the top of the cone off. And actually, the bottom of a cone, some people think if you cut that up and unfolded it, it would make a triangle. But actually, that's not true. It won't make a triangular shape. If you cut the kind of along the side here down to the point and then unravel it, it'll sort of make part of a circle. And it'll make a circle with either a wedge gone, or even sometimes it'll make sort of a triangle with a curved side to it as well. Sometimes it'll look something like this as well. That's what that part might look like. But either way, right, sometimes when you go like this, it's really flat. If you want them a little taller, they'll look like this. But either way, the formula for that gets a little bit complicated because you only have part of a circle there. So it's sort of related to circles with pi r squared and things like that. But some stuff ends up canceling off in this kind of surface area here. So what we would do is we'd say, well, the circle for this yellow circle is right here. That's pretty easy. Pi r squared, we know how to find that. But this lateral area, that's the blue stuff. Lateral means around the side, okay, or to move side to side. So the lateral area is kind of moving around that center point, has kind of a particular formula. It's pi, 3.14, times the radius of the circle times L, not 1 here, this is an L. And L is the slant height. It's however big this height is here. And the reason that that kind of works, a little bit of that, is that whatever height it is here, when you cut that and unfold it, it shows up right here. It's actually the radius of this piece. So it's kind of like pi times r, right? It's kind of like r times r. It's the radius of the yellow circle times the radius of the blue partial circle. So it's kind of like that a little bit. Nothing too extreme, but that's how we'd find that out. So a little bit of an example of how we might do that one. The lateral area here, I'm going to put this into an equation on this one. So if I were to figure out the lateral area here, I would do the radius of the circle times, let's go, oops, too much there. Okay, times the slant height of 12, because that's the radius of this portion, right? It's the radius of this kind of partial circle if we were to cut that. Okay, 5 times 12. And then we also have to take it times pi whenever we're working with circles. That kind of shows up quite a bit. So that's where we would get that lateral area from in that case. And we could do 5 times 12. I'm going to put this in terms of pi. So that's just 5 times 12 is 60. Okay, that's the lateral area. Let's make this a little bigger so everything fits in there. Yeah, that's the lateral area, 5 times 12 times pi. Make it just a little smaller. And now the circle itself, pi r squared. So I'm going to put 5 squared times pi, which you guys know 5 squared is 25. And again, I'm going to leave that in terms of pi. If you want to, again, if you want to change it to a decimal, just like with any of this stuff, you can, although we don't have, you don't necessarily have to. So then the total here is a little bit easier to add up. I would add these two together and say that's 85. And I'm going to leave it in terms of pi. If you want to take a calculator and figure out what that is as a decimal, you can. Now you can always leave it in terms of pi too. So it's a little bit strange. We do have to follow through that formula there. It's not terrible, but you might have to look through here and find out what those different pieces are and then add them up. But again, let me know if you guys got questions. Otherwise, I'll see you later.